Welcome everybody. I am a teacher from Ilm Online Academy. Welcome to another video. Today we are going to have the IGCSE Chemistry revision notes. So in today's video we'll talk about the fourth chapter. As in the previous video we have done with the first three chapters of our contents, and today we'll talk about the fourth chapter. I will show you here the contents which are included in chapter number 4. See on my screen we have chapter number 4, chemical formulae and the equations, and in this chapter we'll discuss about the chemical names and the formulas, chemical equations for the reactions, and also the relative masses of the atoms and the molecules. This is the chapter 4 of the chemistry contents, and in today's video we are going to look at this chapter. So let's talk about this. First of all, chemical formula represents the composition of the molecules and the compounds by using the symbols for the elements and also the numericals to indicate the atoms for each element. Like chemical formula, if we just first talk about the chemical formula, chemical formula represents the composition of molecules and the compounds that are present there. Chemical formula represents the composition of molecules and compounds that are present there by using the symbols. Representation of the composition of the molecules and the compounds by using symbols. For the elements, it is used to indicate the number of atoms for each element. For example, we have the water H2O. Water consists of 2 hydrogen atoms and 1 oxygen atom is present in the hydrogen. We have another example like carbon dioxide. In this we have 1 carbon atom and 2 oxygen atoms are present there to indicate the formula of the carbon dioxide. Next we have an ionic compound which is NaCl. It contains 1 sodium ion and 1 chloride ion is present there to indicate the elements, ions, or the atoms that are present in that formula. So we have some types of the chemical formula that are there, which are empirical formula, molecular formula, and also the structural formula, which we will discuss later in the explanation. Now we will move towards the formula. First you should know about the formula. This is a small introduction about the chemical formula. Now we'll discuss in detail about the formula first. Each element has its unique symbol in the periodic table, and that unique symbol is used to represent that element. Symbol contains, mostly we have this elements which have symbols just 1 letter, but there are some symbols in our periodic table which contains 2 letters. So it depends upon the specific element which we are talking about. If there is just 1 single letter, that is represented by the capital, but if the symbol contains 2 letters, first always capital, and the second one, if there is a second, then second small. First will be a capital and the second one will be the lowercase letter. For example, we have sodium atom that is present in our periodic table, which has the atomic number 11, and this sodium is represented by a specific symbol that is Na. So you can see here two letters are present in sodium and the first one is capital and the second is lowercase. But if there is just one symbol, then you can just write like this. For example, hydrogen has a symbol just capital H. If there is only one letter, then it is represented as a capital. Chemicals combine in fixed ratios that give the full outer shell of electrons. Chemical formula tell the ratio of the atoms that are present in it, as we have discussed earlier about the water. If we talk about the chemicals that are combined together, then the ratio of atoms will be fixed. For example, if we have water, then 2:1, 2 hydrogen atoms and 1 oxygen atoms will be there. Structural formula tells us the way in which the atoms in a particular molecules are bonded together, and for the structural formula we have the specific diagram that is used to show the structure of any element. For example, if we talk about the water, the structural formula of the water, that is represented or done by the diagram or by the written version that represents or that tells the way in which the atoms in a particular molecule are bonded together. For example, the structure of the water molecule will be like this: 2 hydrogen atoms and 1 oxygen atoms will be present there. This is about the structural formula. Next we'll talk about the molecular formula. In the molecular formula, that tells about the actual number of atoms of each element in a molecule of the compound or also in the element. That tells about the actual number of atoms that are present in any particular molecule, or that the actual number of atoms of each element in one molecule of the compound. So molecular formula represents the actual number of atoms that are present there in that formula. For example, we have a compound like butane. The example will be the butane here. Butane has the formula C4H10. 4 carbon and 10 hydrogen atoms are there. So this is the molecular formula for the butane, and structural formula for this will be, this is the molecular formula and that may be represented by MF. If we talk about the structural formula, then the structural formula of butane will be carbon, 4 carbon atoms and 10 hydrogen atoms are present there. So this is the structural formula for the butane. This is the structural formula for the butane. This is the molecular formula for butane. Next, we will discuss about the empirical formula also. The structural formula, this is the empirical formula, and now you should also know about the molecular formula. These are the three different types of the chemical formulas. Molecular formula show the actual number of atoms of elements in a molecule. Structural formula show the arrangement of the atom within the molecule. As you can see here, this is the example of the structural formula. Now we have the empirical formula, and in empirical formula that represents the simplest whole number ratio of atoms in a compound. So in the empirical formula represents the simplest whole number ratio of the atoms in a compound. Simplest whole number ratio. For example, we'll take the example of butane again. Butane has the molecular formula C4H10. C4H10 is the molecular formula, but the empirical formula of butane will be, so empirical formula is the simplest whole number ratio of atoms of each element in a molecule, right? So different empirical and molecular formula of the ionic compounds is always an empirical formula. So for butane, we have the empirical formula C4H10 is the molecular formula. Empirical formula will be C2H5. The simplest whole number ratio from the number from which it is divided, the number of atoms that are present there. So this is the empirical formula of any compound. This one is the molecular formula. This is the structural formula, and empirical formula is present here. You can see here. So these are the different types of chemical formulas: molecular formula, empirical formula, and the last one is the structural formula. So this is how you can give the name of the different elements, and we have read about the chemical formula, molecular formula, and also the structural formula. So now we talk about the rules for naming of the compounds. There are some rules for naming compounds. Compounds are built from the atoms and ions. Giving a name to the compound is the way of classifying the compound itself, and also useful to know that there are some rules to the naming most of the compounds. The name of the compound should tell you which atoms or ions are present in it, so this is more important. There are some basic rules that are useful for the naming of different compounds. For example, the first rule for this will be, if there is a metal that is present in the compound, it is named first. Metals are named first. Metals are named first. For example, we have, I will give you the example of each with the rule. We have a compound which has a symbol NaCl. As you know that sodium is a metal and chlorine is a non-metal, so the metals are named first and then the non-metals. Sodium is present there in this compound, so the name of this compound will be sodium first, and then we have the other atoms that are present there. Chlorine that is present there. When chlorine reacts with any other atom and form the compound, we call it as chloride. So the name of the compound will be sodium chloride. This is the first rule for naming of the compounds. The second will be, when the atom can form more than one ion. Second rule will be, when the atoms or the metals can form more than one ion, then the name indicates which ion is present in it. Like we have iron. Iron mostly have a variable valency because it is included in the transition metals. So iron can form +2 and +3. Iron can form two types of ions, +2 and +3. When the metal can form more than one ions are formed by the single metal, so the name indicates which ion it is present in it. For example, we have iron, then we have Roman numerals like this 2, then chloride. So that means, according to this, Fe2 positive ion is present in this compound. So this is also for the naming of the different compounds. Fe2 positive is present there. If it is iron 3 chloride, then that means Fe3 positive ion is present in this compound. So this is how you can easily check which ion is present there if the metal has more than one ion. The third rule is, compounds containing only 3 elements. If there are compounds containing only 2 elements, have the name ending with the IDE. If 2 elements are there, then if 2 elements are present there, then the name will be end with IDE. For example, we have sodium chloride, we have calcium bromide. Example will be calcium bromide, sodium bromide, magnesium nitride. Compounds containing only two elements have name ending with the IDE. For example, sodium NaCl, calcium bromide CaBr2. There are more than one atoms that are present there, but if in calcium bromide the formula is CaBr2, there are only two types of ions that are present in this calcium and the bromine that are present in it. Despite the number of atoms that are present there, in calcium bromide we have one calcium and two bromine atoms are there, but they are of just two different elements that are present there. So the name will end with the IDE. We have magnesium nitride Mg3N2 with the formula that also ends with the IDE, because this compound contains only two types of elements. The important exception to this is only hydroxide. There is one exception in this rule, which is for the hydroxides. Hydroxides which contain hydroxide ions, OH negative ions are present there, and for that ions we have some exception. So in case of hydroxide, the name does not end with the IDE. For example, we have sodium hydroxide, we have some other examples are present there. So this is the third rule, and the next one, fourth rule, will be compounds containing a compound ion, usually oxygen, that have names end with the 8. Name will be end with 8 if the compounds end with the compound name end with the oxygen. For example, we have calcium carbonate CaCO3. That is the example, calcium carbonate. The name will end with ATE. Another example is potassium nitrate KNO3. We have another examples like magnesium sulfate and sodium ethanoate. All these are the examples which have a compound that ends with the ion like oxygen, sodium, or sulfate ions are present there. So the name will end with the 8. Sulfate or any type of ion, if they are present there, so the name will end with 8. The last one is about, and the last one is the name of some compounds uses the prefixes to tell you the number of that particular atom in the molecule. This is useful if two elements form more than one compound, like carbon monoxide. You can use the prefix. The prefix here is mono because just one oxygen atom is present there. In case of CO2, we have two oxygen atoms, so the prefix that is used here is di. Di means two, mono means one. Carbon dioxide and carbon monoxide. So prefixes are used for the name of some compounds to tell you the number of that particular element that are present in it. As in case of this, there is just one oxygen. In carbon dioxide, we have two oxygen atoms. Other examples of this are nitrogen dioxide NO2. Other than that, we have N2O4 dinitrogen and tetraoxygen or tetraoxide. The name of this compound will be dinitrogen tetraoxide. We have some other examples like SO2 sulfur dioxide. The prefix is di. Sulfur trioxide, and here the prefix is trioxide. So the name of for important mineral acids also follow a logical system, but they are simply learned. For example, sulfuric acid, we have water. Water does not fit with above rules. Ammonia, methane, all does not fit with the above rules. So these are the rules for the naming of the compound that are present there. So we are done with this. Next we will talk about the formula for the ionic compounds and formula for the covalent compounds. Now we will talk about the formula of covalent compounds, and then we'll discuss about the ionic compounds. First, formula of covalent compounds. Atoms of each element have a combining power, and we call it as the valency. Valency is the combining power of the atoms of the elements that are present there. The number of electrons to lose or gain for full outer shell, you can say, or you can use the valency to find the chemical formula. Chemical valency is the number of electrons to lose or gain for the full outer shell, or the combining power of any atom or an element, you call it as the valency. The combining power of an atom in a covalent molecule is the number of bond that makes the atom with that. So valency is about that. Valency of an atom in the main groups for the periodic table can be deduced also from the group number. Like we have groups in our periodic table. The first one, this is the second, third, fourth, fifth, and sixth. Suppose these are the first 6 groups of our periodic table, and according to the group you can easily deduce the valency, or the, you can call it as combining power. Valency will be 1 for the group 1 elements that are present there. 1 if they are present in the group 1. The valency will be 2 if they are present in group 2, 3, 4, up to group 4 we have the valency 1, 2, 3 and 4. In the group 1 we have the elements sodium that is present there, so the valency of sodium is 1. In group 2 we have magnesium. In group 3 we have aluminum, so the valency of aluminum is plus 3. In the group 4 we have silicon. But so for the element that are present in group 1 to 4, valency is the group number, and for the elements up to group 5 to group 7, the valency can be found out by subtracting 8 from the group number. Like you can easily do this up to the group number 4, but from 5 to 7 you can find the valency by subtracting the group number from 8 minus group number. So for 8 minus 5 we have 3, so the valency will be 3. 8 minus 6 we have 2, the valency will be 2. We have phosphorus in the group number 5, and we have sulfur in the group number 6. So these are the examples that are present there. So for the formula of the covalent compounds are found by the non-metals, so the valency can be found out from the group number. For the element that are present in group 8, the valency will be 0, because they are the noble gases, they are the inert gases, they do not react with each other. So valency for group 8, the valency is 0. So you can easily do this, or you can easily find out the formula of any compound that are present in it. Like we can work out the formula of any compounds by this method, involving the symbols and also the valences of the element that are used. First you have to write the symbols of the elements. For example, we have two non-metals. The first one is carbon and other one is the oxygen. These are the two non-metals. They react together, or they make a bond with each other, and we call it as the covalent bonds and the covalent compounds, because both are non-metals. So first of all you have to write the symbols of the elements. Second, you can write the valences of the elements beneath their symbols. Carbon is present in the group 4, so the valency will be 4. Oxygen is present in group number 6, but from group 5 up to the group 7, the valency can be found out by subtracting group number from the 8. Oxygen is present in group 8, so you can easily find out the valency by subtracting it from the 8. So the valency of oxygen will be 2. So after writing down the valences of each elements, then simplify it the ratio that represent there, so you can multiply it, cross multiply with each other. Then we have the formula, which is C2O4. After writing this, if necessary, the simplify the ratio. How can you do this? By multiplying it with the 2, CO2. So the method for finding the formula of the carbon dioxide is like this. So you can do this by a crossover method. This is the crossover method for finding out the formula of the covalent compounds. You can do this also for the methane. Now we'll do another example, or we can find the formula of the covalent compounds by this crossover method. So now we have the compound which is known as methane. Methane is a covalent compound. Now we'll find out the formula of this covalent compound by the crossover method. So the first step for this method, you have to write the symbols for the elements that are present in it. You should know the element that are present in the methane. In methane we have carbon, and also the other element is hydrogen that is present. Both are non-metals, so they form the covalent compounds, and covalent bond is present between them. After writing down the symbols for the elements, you have to write the valencies of the elements beneath their symbols. Carbon is present in the group number 4, so carbon has the valency 4. Hydrogen is present in the group number 1, so hydrogen has the valency of 1. After cross multiplying it with each other, you can get the formula CH4. If it is necessary, then you can simplify the ratio by dividing it with the simplest whole number. So the formula of methane is CH4. You can do this with the nitrogen chloride by finding out the simple molecular formula of the nitrogen chloride. We have ammonia, we have boron trifluoride, we have you can find out the formula of methane, ethane, propane, any compound, the molecular formula. And molecular formula is the actual number of atoms of each element that are present in the molecule of that compound. But empirical formula, as you already know, that is the simplest whole number ratio of the compound that are present in that molecule or in that compound. So this is how you can find out the formula of the ionic covalent compounds. And now we'll discuss about the formula for finding out of the ionic compounds. So let's move towards for finding out the formula of ionic compounds. So for deducing the formula of ionic compound, the valency can tell you the charge based upon the loss or gain of electron. Hydrogen means hydrogen to lose, so it is positive 1 charge that is present, and bromide needs to gain just 1 electron, so the charge on the bromide will be negative 1. So the valency can tell you the charge. Valency can tell you the charge that are present there, can tell the charge based upon the loss and gain of the atoms, that loss and gain of the electrons by the element. The overall sum of the charges must be 0 in the compound. Ionic compounds are electrically neutral. They cancel out the charges because equal and opposite charges are present on it. For example, we have the example of sodium bromide. Sodium bromide is the example. As sodium is present in the group 1, so the charge on the sodium is, sodium has a charge positive 1, and bromine is present in the group number 7, so according to that 8 minus 7, according to the formula, you can find out the valency, that is -1 that is present on it. Bromine needs 1 more electron to complete the valence shell. Cations have positive charge and anions have the negative charge. So sodium, 1 sodium needed for 1 bromide ion, so the formula will be NaBr. This is how you can deduce the formula for the ionic compounds. This is how you can reduce the formula for the ionic compounds. Ionic compounds are solid at room temperatures, so the formula are simply the whole number ratio of the positive to the negative ions in the structures. Another example will be, we have magnesium chloride. As magnesium is present in the group number 2, so the charge on the magnesium, total charge that is present on the magnesium is positive 2. Magnesium is a metal, metals are cations, and magnesium is present in the group 2, the valency will be 2. And in case of chlorine, chlorine is present in the group number 17, and chlorine needs one more electron to complete the valence electron. So as ionic compounds are electrically neutral, so you can have to take, so in that case of magnesium chloride, there are 2 chloride ions for each magnesium ions to cancel out or to balance this. So 2 chloride ions are needed in this. So the total charge on 2 chloride ions will be -2. The chemical formula for this one will be Mg Cl2. The overall structure must be neutral. The positive and the negative charges must balance out each other, because there are giant structures. Ionic compounds are always represented by their chemical formula, and the crossover method can be used to work out the formula that are present on that. So in ionic compound, the valency of each ion is equal to the charge that are present there. Mostly metals that are present in the group 1 and group 2 are they are cations and they gave their electrons, and non-metals are mostly gain that electrons from the metals. So you can work out the formula of different compounds, like for working out the formula of aluminum oxide. First you have to write the symbols. The symbol for aluminum is An and for oxygen is O. Then you can have to write the charges that are present on it. Aluminum has positive 3 charge, and on oxygen we have -2. So after cross multiplying it, what we get, we have Al2O3. That is the formula for the aluminum oxide. So by this crossover method, you can easily find out the formula of the ionic compounds and also the formula for the covalent compound. The same rules apply while writing the formula of the compounds containing the compound ions, because each of them has the overall charge. So this is useful to put the formula of the compound ions, showing the formula of each ion that cannot be changed. So this is how you can find out the formula of the ionic compounds, and also for the formula of the covalent compounds. And next we'll discuss about the chemical equations. Now first we have discussed about the chemical formula, and now we'll discuss about the chemical equations. Chemical equations represent the chemical reactions, showing the reactants as the starting materials that are present on the left side of the equation, and the products which are the substances that are formed along with their quantities. A balanced chemical equation has the same number of atoms of each element on both sides of the equation. We have, in chemical equations, we have reactants that are present mostly on the left side, and we have products. These are the substances that are formed after the chemical reaction, and a balanced chemical equation has the same number of atoms of each element on both sides of the equation. For example, hydrogen and oxygen gases react together to form a product that is known as water. So in this, hydrogen and oxygen are the reactants, and H2O is the product that is formed after the reaction between the hydrogen and the oxygen. This equation is not balanced. A balanced chemical equation has same number of atoms of each element on both sides of the equation. But you can see here on the left side we have 2 hydrogen atoms, and on the right side also 2 hydrogen atoms. But in case of oxygen, 2 oxygen atoms on the left side and just 1 oxygen atom on the right side. So for the balancing of the chemical equations, same number of atoms must be present on each side that is present there. So you have to balance it by writing numerals in the coefficient of any element. Like For example, for the balancing of the equations, here you can write the 2 before H2O. For the balancing, you only have to write the numbers in the coefficients. Now we have 4 hydrogen atoms and 2 oxygen atoms on the right side, but 2 oxygen atoms and 2 hydrogen atoms are present on the left side. So just write the 2 before hydrogen gas. Now it is balanced. So this equation is now balanced. There are components of the chemical equation which are reactants that are present there. These are the reactants that react together and form the product. These are the substances that are used for the chemical reaction. They undergo a chemical change. They are present mostly on the left side of the equation. These are the products. These are the substances that are formed as a result of the reaction between the reactants, and they are present on the right side of the equation. We have coefficients. Coefficients are the number placed before the chemical formula to balance the equation. This is the coefficient and this one is also the coefficient. So these are the coefficients that are present there and they are placed before the chemical formula to balance the chemical equation. So the group of atoms, like we have some atoms, mostly hydrogen, nitrogen, fluorine, oxygen, chlorine, bromine and iodine I2, must be diatomic while writing the chemical equation because they are present in the diatomic state. They are stable in this diatomic state. We have subgroup of atoms like nitrate ions, NO3, sulfate, SO4. These are the group of atoms like nitrate, sulfate that has not been changed from one side to another, counted as a group, not as the individual atoms. So these are the rules for writing and balancing of the chemical equations. First is the simplest one. Same number of atoms must be present on the each side of the equation. So this is about the chemical equations. So we have two types of equations. The first one is the word equation and the second type is the symbol equation. There are two types of the equations, word equation and the symbol equation. The simplest way to do this is in the form of the word equation. This type of equation link together the name of substances that react together with those of the new substances that are formed. For example, we have magnesium. You have to write it in the words plus oxygen that react together and they form the magnesium oxide. So this one is the word equation. This type of equation link together the name of the substances that react together like reactants with those of the new substances that are formed, which are the products. So the word equation for burning of magnesium in the oxygen would be like this. We have magnesium and oxygen. These are the reactants that can be shown by the R, and magnesium oxide, that is the product. This is formed by the reaction between the magnesium and the oxygen. Next, I will show you here about the symbol equation. Symbol equation is by writing the symbols of the elements magnesium plus oxygen react together and they form the magnesium oxide MgO. This equation is not balanced, so you can balance it by writing the coefficients like this, 2Mg. After we have to write in the products also the 2 in the coefficient of MgO. So this is the symbol equation that can be used for the different chemical reactions. Symbol equation should be balanced. The symbol equation is a balanced chemical equation. The number of each type of atom are same on both sides of the reactant and the product side of the equation. There should be 2 magnesium and one oxygen molecule is present there on the reactant side, and we have two molecules of magnesium oxide that are present on the product side. So a balanced equation gives us information about the reaction, and we can get the simple word equation from that one. So this is about the symbol equation and the word equation. Next, I have some example. So now we'll write the balanced equation for the reaction between the hydrogen and the oxygen. Like we have another example. When hydrogen and oxygen react together, they produce the water. Each molecule of water contains one oxygen atom and two hydrogen atoms are there. It follows that one molecule of oxygen has enough oxygen atoms to produce two molecules of water, 2H2O. For example, first make sure you know what reactants are present there. So we have to write the reaction between the hydrogen and the oxygen. First, you should know about what reactants and products are there. For example, hydrogen reacts with the oxygen. So hydrogen has the formula H. Symbol of hydrogen is H, and oxygen has the symbol O, O2 gas. From this you can write the word equation also. Hydrogen plus oxygen. After reaction we have water. This is the word equation. After writing that, write the equation using the formula of the elements and the compounds. Hydrogen plus oxygen. After that we have water, which is H2O. Remember that oxygen exists as the diatomic molecule, so this equation is not balanced. There are two oxygen atoms on the left side but only one on the right side. So first, now you can balance this. Now work through the steps to find the balance symbol equation for the reaction that takes place when hydrogen reacts with the oxygen. So for that purpose, what you will do, you have to write the 2 here and 2 here, so the equation is now balanced. You have to write in the coefficients for the balancing of the equations. There should be a balanced chemical equation. We cannot alter the formula of the substance that are involved in that chemical equation. They are fixed by the bonding in the substance itself. You can only put in the multiplying number or just into the coefficients. You can write only in the coefficients in front of each formula where it is necessary. Chemical reaction do not involve the elements that are react together. In most of the reactions, compounds are involved. For example, we have the potassium and also the hydrogen gas that react together, and when they react they form the potassium hydroxide and hydrogen is produced, right? So this is another example for the symbol equation and also the word equation. Now let's talk about the symbols that are present in the symbol equation. So the next topic is about state symbols. State symbol, these are written after each formula to show the physical state, for showing the physical state of each substance that are present there. Physical state of each substance is represented by the symbols. We have some symbols that represent there, like for showing the physical states, S represents the solid, L represents the liquid, G represents the gas, and AQ represents the aqueous. Aqueous solution means that is dissolved into the water. So these are the symbols that are used in different chemical equations. For example, we have the equation magnesium, a small s is present there, that react together with the nitric acid. Nitric acid is present into the aqueous form, AQ. After reaction we have magnesium nitrate, and the state of this is aqueous, plus we have hydrogen gas that is present there. So the example here show how the state symbols can be used. This is S is for the solid, AQ is for the aqueous solution, magnesium is present as in the solid state, nitric acid is present as an aqueous solution. We have the products magnesium nitrate, and this magnesium nitrate is also in the aqueous solution, and hydrogen gas is produced. So these are the symbols that are used to show the physical state of the reactants and the products that are present in the ionic that are present there into the chemical reactions. So you can also deduce the symbol equations just by working out the formula and state the symbols of the reactants in the product to construct an unbalanced equation. So the second step is just balance out the equation. So the next one is about the ionic equations. We have some equations that involve the mixing solution that contains the ions. Only some of the ions present actually change their state. Like now we have the ionic equations. In ionic equations, some of the ions present actually change their status by changing either their bonding or their physical state. The other ions are simply the spectator ions. There are two types of ions in our chemical equations. First, we have the spectator ions that are present there, and the other ions present are simply spectator ions to the change. These ions are present during a chemical reaction but do not take part in the chemical reaction. Do not take part in the chemical reaction, and their state does not change. But some of the ions present actually change their state by changing either their bonding or also by the physical state. So we have an example for the ionic equation and also for the spectator ions. For example, HCl that is present in the aqueous solution react together with the sodium hydroxide that is present also in the aqueous solution, and when they react together they form NaCl, which is the salt which is soluble in the water, and we have water, H2O, that is present into the liquid form. When the water itself is produced in a reaction, it has a symbol L for the liquid, not for the aqueous. So you have to write the L like this for the water. So you can work out all the ions that are present there. After working out, we have hydrochloric acid contains H positive ions that are present there plus chloride ions. First, you have to writing out all the ions that are present in that equation. Hydrochloric acid contains the H positive and the chloride ions. Both are in aqueous form. You can easily check from the equation. Plus, we have sodium ions in the as in base, that is also in the aqueous form. Plus, we have hydroxide ions also in the aqueous form. After reaction, we have Na positive ions into the aqueous form, plus we have chloride ions also into the aqueous form, plus we have water, H2O, as a liquid. So after writing out all the ions that are present there, we have this equation. So you have to check which ions change their state when they react together. So you can easily check this. Hydrogen that is present there is in aqueous form. Chloride ions are in aqueous form. So you can easily cut these chloride ions with this one because chloride ions does not change their state. Sodium ions change same state before and after the chemical reaction, right? So you can easily check out here hydrogen and hydroxide ions are present in the aqueous solution. aqueous form before the chemical reaction, and after the chemical reaction we have the water H2O that is present into the liquid form. So the use of state symbol clearly show which ions have not changed during the chemical reaction. They have been crossed out like this and can be left out of the ionic equation. This leaves us with the essential ionic equation for all the neutralization reactions. We have H positive ions. So these are the spectator ions. These are the spectator ions which does not change their state or do not take part into the chemical reaction or the chemical change. Hydrogen ions that are present in the aqueous solution first, and also the hydroxide ions that is also present in the aqueous solution. When they react together they form the water which is H2O, and the state is now the liquid L. So this is the ionic equation. We can apply the same principle to also the precipitation reaction, that also give us which ions are reacting and which are not. So the water, when itself produced, you in a chemical reaction, it has the symbol L for the liquid, not for the aqueous. The one which are present in the solution, you can write there for the aqueous for those ions, not for the water. So this is how you can easily calculate or check out the ionic equation, which is a simplified equation for the reaction involving the ionic substances. Only ionic equation is for those ions which actually take part in the chemical reaction, as shown here. Hydrogen and hydroxide ions take part in the chemical change and in the reaction, and the state changes from the aqueous to the liquid. So now we'll move toward the third content of our chapter, which is about the relative masses of the atoms and the molecules. So we have relative masses of atoms and the molecules. There are 118 different non-elements in our periodic table, and all have different mass. The mass of those atoms of these elements are really small and hard to work with, which we use something that is known as the relative atomic mass. We have some standard, like atom of carbon. Atom of carbon is used as a standard and is given a relative atomic mass of 12. So in simple words, relative atomic mass is represented by AR, is the average mass of the isotope of an element that is compared to the 1/12 of the mass of atom of carbon 12. This is the relative atomic mass of any element. So the relative atomic mass of carbon is 12 and the relative atomic mass of oxygen is 16. So this is how the relative atomic masses are compared, and these are shown here. So the relative atomic mass is the average mass of the isotope of an element compared to 1/12 of the mass of atom. And next we have relative molecular mass. Relative molecular mass is represented by MR. Relative atomic mass is by AR, and MR is relative atomic mass. And relative atomic mass is the sum of the relative atomic masses. They are used for the ionic compounds. For ionic compounds we can use relative atomic mass, we have relative molecular mass, we have relative formula mass, we have formula units. So relative molecular mass is sum of all the relative atomic masses of the element that are present into the molecule or in the compounds. For the ionic compounds, you can also use the word which is known as formula unit. Formula unit, this unit of an element of a compound is the molecule or group of ions that are defined by the chemical formula of that substance. So we have relative molecular mass, we have relative atomic mass, and also the relative formula mass. The sum of all the relative atomic masses of the atoms that are present in a substance is the formula unit of any element that are present there. So we have we have compounds to calculate the relative atomic masses. Masses cannot be created or destroyed. We have relative atomic masses of different elements that are represented by our periodic. You can see here on my screen, this is the periodic table, and from the periodic table you can easily check the relative atomic masses of any element that are present there. For example, you can see here, this is an element hydrogen, the first element of our periodic table, and the atomic number is 1, and the atomic mass that is present here is 1.008 of the hydrogen. So this is the relative atomic mass of any element that are present in the periodic table. Relative atomic mass of helium, as you can see here, which is 4.002. For relative atomic mass of chlorine is 35.4. Relative atomic mass of carbon is 12.0, and carbon is also used as a standard for the relative atomic masses. So for the relative atomic mass is the average mass of the isotopes of each element compared with the mass of the carbon-12, and relative formula mass is the sum of the relative atomic masses that are used for the ionic compounds. We can easily calculate the reacting masses from the equations also. For example, when magnesium reacts with the oxygen to form the magnesium oxide, like when magnesium react with the oxygen to form magnesium oxide, what will happen? You can easily balance it by writing in the coefficients. We have 2 magnesium atoms, as you can see here, 2 magnesium atoms on the left side, plus we have 2 oxygen atoms. When they react together, they form magnesium oxide. 2 magnesium oxides are formed, 2 magnesium atoms are present there, and 2 oxygen atoms are present also on the right side of the equation. So magnesium has, you can check the relative atomic mass of magnesium from the periodic table. As magnesium is present here, the relative atomic mass is 24, and for oxygen the relative atomic mass here, that is 16. These are the relative atomic masses of the magnesium and the oxygen. So the relative atomic mass of one magnesium atom is 24, and oxygen has the relative atomic mass of 16. So this one is the equation. I am again writing this. After reaction we have 2 MgO. You have to multiply the coefficient with the relative atomic masses plus 2 with the 16, and after reaction we have 2 into 24 plus 2 into 16, like this one. After simplifying it, now you have 24, 2 into 24 we have 48, plus 16 into 2 we have 38, equal to 24 into 2 we have 48, or plus 16 into 2 we have 32. So it is equal to 80, 48 plus 32. So for the product we can work out the inner bracket first. So 48 grams of magnesium react with 32 grams of oxygen to form 80 grams of magnesium oxide. The proportion in which the magnesium and oxygen react together are defined by the chemical equation for that reaction. So you can easily calculate the amount of the compounds that reacted together as or produced into the reactants. For example, we have some other examples. You can take the example of the reaction between the hydrogen and the oxygen, and also you can take the reaction between the potassium and the bromine. They react together to form the compounds, and you can easily check out or work out the formula and also the relative atomic masses of these compounds that are present there. So the value of relative atomic masses can be used to calculate the relative formula mass of the compound, and this information can be used to calculate the masses of the substances that are involved into the chemical equation. So this is all about the fourth content of our book, which is about the chemical formula and the equations. Hope you enjoyed it. If you have any query or any confusion, you can ask in the comment box. All right, we'll meet in the next